Hello everyone, in this video I'm going to give you a quick overview of my progress report for my final project. So for my final project I decided to modify a climate change net logo model, and I'm going to start by showing you the modifications that I made. So firstly I added 4 different land types, so now I have vegetation, soil, water, and ice. I added sliders so that the user can control the albedo values for each land type. I also added sliders so that the user can increase and decrease the amount of vegetation and ice in the model. I also added some code so that sun rays interact differently based on the land type that they hit. So if they hit the vegetation, they're going to interact based on the albedo for the vegetation. If they hit the soil, they're going to interact based on the albedo for the soil, and so on. I added the functionality so that once global temperature reaches 25 degrees Celsius, it's going to start melting at a rate of 0.0001. I added code to ensure that rays reach all land types, because in the original model they would only hit a specific area of the surface. So I'm going to show you the model real quick. So as you can see, ice starts melting after 25 degrees. I can control the amount of ice here. I can control the amount of vegetation here. Um, so for my verification and validation, I'm going to run 3 tests. The first test, I'm going to set the albedo values um, according to this table, and I basically expect all the rays that hit the vegetation and water to be absorbed, while the rays that hit the soil and ice to be reflected. So here's the setup for that. Here are the albedo values and all the land types. So test number 2, I'm going to set these albedo values, and I basically expect the global temperature of the new model to go up faster since water absorbs more energy. There's no water in the old model. And for test number 3, I'm going to set this albedo values in the old and new model, and I expect the temperature in the original model to rise faster since there's no ice on the old model. Ice clearly reflects a lot of energy. So some of the assumptions I made for the model is that there's no day and night. There's only daytime represented. There's no rain or other weather phenomena like hurricanes. There are no seasons like winter and summer. There's no human interactions, and there's no burning of fossil fuels. Of course, there's many more, but those are some of the main ones. And as for the testing against real world data, I'm gonna run my model and basically compare it against this table that has temperatures for different decades here, for the couple past decades, and I'm gonna compare them. And then what's left for me to do, basically just run the tests and write down the results and analyze them. Thank you.